Hello and welcome. My name is Elizabeth Moreno and I'll be presenting on the golden ratio today. This presentation was originally designed for Math 318 number theory, taught by Professor Cohen. So to begin, what is the golden ratio? The golden ratio actually begins with something known as a golden mean. If a plus b over a is equal to a over b is equal to phi, then phi is known as a golden mean. Golden mean is generally a number with this form, whereas the golden ratio is a specific number that takes this form. When a over b is equal to phi, or b over a is equal to 1 over phi, phi equals 1 plus the square root of 5 over 2, or approximately 1.618. This specific number is the golden ratio, which is the most famous of the golden means. So how is the golden ratio related to number theory? It can be derived from the Fibonacci numbers. A number f sub n is equal to the sum of the two values prior to it, beginning with 1. 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and so on and so forth. In order to find a specific Fibonacci number, the formula is 1 over the square root of 5 times 1 plus the square root of 5 over 2 raised to the n minus 1 minus the square root of 5 over 2 raised to the n. Also, when you take the limit of f sub n over f sub n minus 1 as x approaches infinity, the limit will approach the golden ratio. For a visual representation, the golden ratio appears as a spiral that can be built with blocks of sizes that relate to the Fibonacci numbers. Many times, this infinite spiral can be found in paintings, such as the wave on the left. The curve, the golden spiral, and the squares that make up the curve can be seen within the art for emphasis of this visual. So the golden ratio occurs commonly in art, but it also occurs very frequently in nature. It's very common for things such as plants, seashells, or animal proportions to follow the golden ratio. It can even be found in relation to black holes, their structure, and the motions of the photons around them. And it has also been found in connection with certain chemical alloys, magnetic compounds, and even human attractiveness. Moving on to some specific examples, the golden ratio can be found in relation to different chemical alloys. The first listed here is an iron-based compound that also contains carbon. The golden ratio appears as the proportional differences in the weight of the compound during different phases, specifically the fraction of the ferrite phase to the pearlite phase. The second compound, made up of copper and zinc, contains the golden ratio in relation to the mass percent of carbon within the compound. The golden ratio appears in the final compound, copper and tin, more commonly known as bronze, as the percent at which the bronze alloy system is entirely tin. Some of these golden ratio related compounds also have some connections to magnetic fields, which in turn are relative to particle physics and quantum field theory, as well as string theory. Extending into the realm of quantum theory, the golden ratio can be found in relation to a specific type of black hole. This specific type is known as a Schwarzschild-Kottler black hole, a black hole that exists on either a flat, de Sitter space, or a curved, anti-de Sitter space, spacetime. Schwarzschild black holes are the most basic kind and do not have any charge or momentum whatsoever. Photons, or particles of electromagnetic radiation that exist without mass, can be found near and outside of the black hole, such as those seen in the first ever photograph of a black hole. They are therefore known as null particles. These particles take on paths known as null geodesics, and in relation to Schwarzschild-Kottler black holes, the related photons exhibit these null geodesics with a path very close to the golden ratio. All of these findings have been found to be completely independent from the cosmological constant lambda. Moving on to practical applications, the golden ratio can be found in everyday devices, such as medical devices. One of these is the MRI, or the magnetic resonance imaging machine. The golden ratio has been used to help improve and create these images by using tiny mathematical calculations in order to refine the images that are taken, providing better image quality overall and allowing doctors to better treat their patients accordingly. To summarize what we've discussed today, there are numbers known as golden means that take the form a plus b over a is equal to a over b is equal to phi. The most notable golden mean is the golden ratio, where phi is equal to 1 plus the square root of 5 over 2. This ratio appears across vastly different fields such as psychology, physics, or even quantum mechanics, and it also has practical applications such as those in the medical field, specifically in devices such as MRIs. All of the sources referenced in this presentation can be found here. Thank you.